Find the discriminant of each quadratic equation, then state the number and type of solutions. So, first things first, b squared minus 4ac. So, b squared, negative 5 squared, minus 4 times a times c. So that'll get me 25 minus 8 times 4, 32. And that'll get me, what, negative 7? So that's my discriminant. No real solution. There are two imaginary or two complex. Okay, this one, b squared minus 4ac. I get 64 minus 12 times 4, which is 48. So I'm going to get 16. So that means two real solutions. And then over here, negative 6 squared minus 4ac. I get 36. And that'll get me negative 36. That'll get me 0. So one real solution. Then it says describe the number. So no real solutions, but there are two imaginary or two complex. There is one real solution. This one. Okay, so if I was to do 14 divided by 4, that would go in, what, 3 times? So I have to the 12th times squared. Remember, I to the 4th and the multiples of 4 are going to be 1. This would be negative 1, so my answer is negative 1. Okay, 54 or 53. 4 goes in, 1 goes in, sorry, that's 4. That would go in 4 times 3. 12. So there's 1. So 52. With 1 left over. So this is 1, and this is I, so my answer is I. Okay, 256 is divisible by 4, so my answer is 1. 63. Hopefully you know that 4 goes into 64 evenly, but if you don't, we'll do this. It goes in 1 time 4. I will get 2, bring down the 3. That'll go in 5 times, so I'll get 3 left over. So, I to the 60th times to the 3rd. You may be asking, how do I know what the answers are? This right here tells me what this one's going to be, so I just subtract the exponents. So this is going to get me 1. Okay, I'm going to split this up to I squared times I. So, this is negative 1, this is I, so negative I is my answer. Okay, find the real values. Okay, so this is the real number, this is the real number. So I set them equal to each other. And I solve, so x equals negative 4/3. Then I'm going to pick a different color. This is my imaginary number. So I take 7y and I set it equal to negative 21. I divide by 7 and I get y equals negative 3. Over here, this is my real part. This is my real part. So I set them equal to each other. Subtract x, I get 2x equals 4. So x equals 2. Then I take my imaginary and I set it equal to each other. 4y minus 3 equals negative 5y equals, or plus 15. Add 5y, I get 9y minus 3 equals 15. Add 3 to both sides, and I get 18. Divide by 9, and I get 2. Down here, evaluate it. Well, the square root of 49 is 7. The square root of 9 is 3. So my answer is 21. Here, this is 7i times 3i. So I get 21i squared. I squared is negative 1, so I get negative 21. This one is 7i times 3, so 21i. This is 7, this is 3i, so 21i. How do real numbers relate to complex numbers? They're the first, because we always have real plus imaginary. Then if you're talking about graphing it, this line right here is the real number line, where this right here is the imaginary. Okay. What makes a rational number? A number that can be made into a fraction. Okay, so we're going to express all of this with the real number first and then the imaginary second. So 5 minus 3i minus 6 plus I, so that'll get negative 1 minus 2i. Next, I have 5 plus 7i plus, that'll be minus 6 minus 18i minus 3 plus 3i. Real number, real number, real number. So that'll get me negative 4, imaginary, 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 and that would get me negative 8i. This one, so 4 plus 2i times 4 plus 2i, I would get 16 plus 8i plus 8i plus 4i squared. This right here changes to negative 4. So if I combine like terms, I would get 12 plus 16i. Over here, negative 21 minus 27i minus 14i minus 18i squared. Again, this will change to 18. So I would get negative 3 minus 41i. Okay, graph. So the real number goes on the real axis. So negative 4. So I come over to negative 4 and I go down 3. So this one is negative 4 minus 3i. Then I again go to my real number first, so 3, and I go up 5. So this is going to be 3 plus 5i. Oh, I think I'm supposed to be doing A, B, C. So this is B. This was A. C. I do negative 3, so I go to the left 3, and I go up 5. So this would be C. Then all I have is a real number. So that's my real number. The next one, all I have is an imaginary. So I come down here, and that's going to be letter E. And did I do purple yet? No. So then I have another imaginary without having a real. So that's F. And I think I'm going to have to repeat a color. So I'll repeat. Oh, I have this blue that I can do. So I'm going to go +2 and I'm going to go down 4. And that's G. And then I'll repeat. Oh, I didn't do green yet. So I go +2, but I go up 4I. And that would be H. Okay. Looking back at 16, B and C. How are they related and what geometric relationship do they have geographically? So, if I look at these two, they're real numbers are the opposite. So that makes them a reflection over the imaginary axis. And then their imaginary number is the same. Okay, state the conjugate. 8, 3 plus 7i, negative 5i, and negative 6 plus 2i. Okay, so we're going to divide these. So I have to multiply by 2i because I multiply by the conjugate. So I get 6i minus 14i squared over negative 4i squared. This right here turns to positive 14. This turns to positive 4. So I get 14 plus 6i over 4. I can factor out a 2. And I would get 7 plus 3i all over 2 times 2. The 2's cancel out, and I get an answer of 7 plus 3i all over 2. Okay, and then this one, I multiply top and bottom by 2 plus 3i, 2 plus 3i. When I do that, on top I'm going to get 12 plus 18i plus 2i plus 3i squared all over 4 minus 9i squared. This will change to negative 3. This will change to positive 9. So I will get 9 plus 20i over 13. Okay. Given the following, write in standard form. Okay, so it wants p of x. So that means x minus 3, x plus 4. Why did I do that? X minus 2i and x plus 2i. Okay, so I'm going to multiply the first two. And I get x squared plus 4x minus 3x minus 12. And then I get the second one, so x squared minus 4i squared. This part right here changes to a positive 4. Sorry about that. P of x equals x squared minus x minus 12 times the quantity x squared plus 4. So then I multiply those together. P of x equals x to the 4th plus 4x squared minus x to the 3rd minus 4x minus 12x squared minus 48, and then I put it in descending order. So x to the fourth, then I have a x to the third here, so minus x to the third, x squared here and x squared here, so minus 8x squared minus 4x minus 48. Okay, so circle all that apply for each of the following. This is just a complex imaginary. So this is an integer, it is rational, and it's a real number. The square root of 32, 32 is not a perfect square, so that is irrational. Irrational numbers are real. This is a complex number. This is an irrational number and it's real. This would get 1, so that's natural, whole, integer, rational, and real.